Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. And also at the end of today's webinar, we will be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our two lucky winners. Okay, with that, we'll go ahead and kick off today's webinar, which is Developers Driving DevOps at Scale, 5 Keys to Success. Our speakers today are Charlie Betts, who is Lead DevOps Analyst at Forrester Research, and Lorelei Catapan, who is Senior Director of Product Management at JFrog. Welcome to you both. Thanks for joining me today.
Greetings.
Charlie, greetings. Well, I know you've got a great presentation on tap, so I'm going to put myself on mute and let you get right to it.
Excellent, and thank you so much, and thanks to JFrog for having us here from Forrester to talk about these very important topics. I've got a lot of passion for DevOps, and I think that JFrog is really taking a leading role here. So super excited to get to the message. So a little bit of a history lesson here. We are coming out of the industrial era, and what did that mean? Well, it meant that back in the day, you had the lab. And the lab was where the great inventions were created by the great inventors, the Alexander Graham Bells, the Thomas Edisons, the Teslas, and all the rest. And then once we had the great invention, we used the power of the industrial revolution, the massive supply chains, coal, oil, electricity, steam, and we would create highly repeatable products at heretofore unprecedented scale and distribute them out to the new mass market. And there was a lot of learning, there was a lot of development. We created the new mass economy, but to a certain extent, it was highly predictable. You used concepts and methodologies like Six Sigma to drive variation out of the process. You wanted to simplify, to make things more efficient. And we are now in a very different world. We are in a world, the term that is coming up more and more lately is VUCA. Volatile, uncertain, complex, and ambiguous. And I don't think you have to look very far today to realize that this is, I think, a much better description of the world we are in than a highly deterministic and linear and predictable assembly line. We are in a world where we do not know what we are going to be facing in the next few weeks, let alone months and years. Everybody's 3 to 5 year strategic plans have been thrown out the door. And what do they get replaced with? Well, this has been the key point of DevOps. It's not just about getting functionality to the market more quickly. That's a good thing. Don't get me wrong. It's important that we release needed functionality to our customers and stakeholders. But if we focus simply on time to market, we risk overlooking, I think, a deeper point that it's about business experimentation, that in a VUCA world, a world of unknown unknowns, the way you discover what your path needs to be must be through experimentation. You have to develop hypotheses and you need to probe on these hypotheses, sense the response of the chaotic VUCA world to your probing and investigative efforts. And then when you start to realize that you may have discovered a newly profitable or valuable avenue of discovery, then and only then do you pivot, you start to double down, and then you start to realize that maybe I have a new way of delivering value in this world that I hadn't realized before. but how do we keep up with the speed of business? How do we keep up with the need of business to continue experimenting, to continue innovating, especially in such uncertain times? Well, in 1959, a great management theorist by the name of Peter Drucker said that while the 20th century will be the century of the manual worker, the 21st century will see the rise of the knowledge worker. And sometimes predictions absolutely ring true. Sometimes a non-obvious prediction like this absolutely nails it. And this is 60 years ago, and we are still working through what Drucker saw in 1959, that the knowledge worker would absolutely become the primary store, the primary driver of value in the modern economy. And how is the knowledge worker different from the manual worker? Well, there are a number of dimensions that we could talk about, but I think the most important dimension is that the knowledge worker requires autonomy. A worker on an assembly line moving a wrench in a given set of motions every day, repeatedly, time after time, that worker does not necessarily need autonomy. They need to know what the best practices are. It absolutely makes sense to say, time and motion studies will indicate that there's an optimal way to hold that wrench. But when you have a problem of discovery, a problem of unknown unknowns, it is not possible to say that there are best practices. What instead you need to realize, and we looked long and hard for this particular picture, notice that her back is more or less towards us. She is looking into the unknown. She has autonomy. She has a sleeping roll. She has provision. She has a backpack, probably with a rain jacket in it. She has water. She does not need to turn around and come back and ask for permission. She may have been given a clear mission, find your way across that valley, but we can't know what she's going to encounter as she progresses across that valley. Those are the unknown unknowns. And this is the perfect metaphor for the semi-autonomous, the relatively autonomous product team. Now, you still need overall alignment to the mission. And this is an important point. It's not that she's free to just go off in any particular direction, but once the general parameters of her quest have been set, she is in the best position to understand what it will require to get to where she needs to go. And this is very different from our previous concepts of economic value. So if I was to look at how we thought about industry, this is called the value chain. It's by another management thinker named Michael Porter. And Michael Porter believed that real value consisted of the operations along the bottom. You needed to find raw materials. You needed to then manufacture them into finished goods via an assembly line. You distributed them via outbound logistics, sales and marketing to the mass market, and then you serviced them. Technology development, and by that I mean R&D, was seen as overhead, burden. All of the stuff on top is considered burden. It is burdening the true value, including the information systems that we see at the very top there, the old computer with the tape drive. And this is a very traditional view of value, of economic value. But now what we are seeing, in particular, what I want to talk about is the relationship between operations, service, research and development, and information technology. And while I could talk about how all of these, when we split them apart, that has had certain consequences that have made it harder to digitally transform. And in the digitally transforming world, what we're seeing is all four of these things are coming together in unique and innovative ways. And at the center of those green arrows, I think that's where DevOps lives. And in particular, I want to talk about this idea that R&D is overhead. It's baffling. And yet I've had a lot of conversations, with senior colleagues, Forrester analysts, economic thinkers, and everybody agrees, yeah, R&D, even though it was the great and many times the great inventions, going back to people like James Watt, or I mentioned Thomas Edison, that really were the sparks of value. Innovation in R&D was not predictable enough, and so it really became kind of a nice to have. If you had a good product concept and you could run with it, then really manufacturing it was where the value was. And if the people in the lab came up with new stuff, well, that was nice. But you didn't really consider it as core to the value chain. And Harvard and Michael Porter, Harvard Business School professor Michael Porter, did not put it in the value chain. But this is where here at Forrester, we are actually being so bold as to say, no, Porter may have gotten it right for the manufacturing era, but in the new era of DevOps and digital transformation, research and development belongs on the bottom. Research and development as represented by the DevOps figure 8. And this is a figure many of you may have seen before. You code, you build, you test, you release, deploy, operate, monitor, and then you go back into the planning cycle. And you continuously iterate on that. And notice that you, in fact, are coming up with new hypotheses, you are researching, you are developing, you are implementing, you are testing, you are reassessing the results of your tests, and then you're replanning. And this iterative continuous cycle is where digital value exists. And it's increasingly what all companies need to do for all of their systems. Now, there's a couple other nuances to this diagram. Notice that everything has a little figure 8 on it. So we see that there is a need for services across the organization. We need CDRA services right there in the middle, the long gray box. We need enterprise service management so that we can get to other corporate services like legal, finance, HR, sales, and so forth. And then, of course, we have more automated services, and there's a whole trend from top to bottom as we move from human to human services and automate them into machine to machine services at the API level. And notice also that we have product thinking for external stakeholder value, as indicated bottom right, as well as the fact that all of the internal functions themselves are being run as products as well, because everybody needs to be experimenting and continuously improving, especially the automation and the reliability of their services, because any of these business services can be key to unlocking the overall value to external stakeholders that this diagram implies. And so DevOps becomes the core value chain. It becomes the means by which we research and develop and deploy to the market, and then sense the market feedback and feed that back into the next generation of our digital products. Now, one of the things I like about DevOps is that we've started to really establish what a reference architecture looks like. There are many variations on this. I've seen one company that has put out a number of reference architectures, and I'm really glad that we have some consistency of thought around this. We understand now that source is kept in a source repository. We no longer put binaries in the same repository as the source repository. Instead, we use build automation to transform the source into the deployable packages. In the source repository, of course, we have code as code, application code, but we also have infrastructure as code. And most recently, we have pipeline as code, so that we, as code, represent the process by which the source code is transformed into a deployable package. And furthermore, the process by which the deployable package is then combined with infrastructure resources and turned into valuable digital services that can be accessed in real time. And of course, one of the other aspects, which I'll talk a little bit more about later, is that the package repository is not just for the stuff that we build internally, it's also for all of the resources that increasingly we bring in from the open source community and from our commercial vendor partners. And to that point, more and more, the developer no longer just starts by writing code. They start by looking at how other people have solved similar problems. They start by downloading things from GitHub and Stack Overflow and GitLab and all the rest. Typical project may create many new dependencies on various open source and commercial products. And so how do we manage these dependencies? Historically, we've used enterprise architecture, and speaking as a former enterprise architecture, I was a lead enterprise architect. I was a lead architect with Wells Fargo for 6 years, and before that at Best Buy and Target. We used to put in some pretty tall walls and say you must go through the process and be approved. But these big gates are falling out of favor because they introduce too much friction. They introduce too much cost of delay as you seek to innovate and as you realize that, hey, I need to beat this other company to market. These processes that you put in place to reduce risk may actually be adding risk to your company if it means that your competitors are going to be faster to market than you. This is a hard lesson, I think, for some risk professionals to swallow. And so we see this continual tug of war between innovation and other concerns that remain reasonable and important concerns. Every new product we bring in from GitHub or download from other open source repositories, that expands our attack surface. Do we really need 15 different flavors of database? What about technical debt as we continue to proliferate products, some of which may be redundant and then some of which start to gain more use and others start to fall aside, but we haven't sunset them completely? We start to see more and more technical debt. We may see drift from what the approved standard was. We may look at something and say, yes, well, this is an okay product as long as we keep it well patched and up to date. But if it starts to drift away from what the approved patch level should be, that can be a security risk. And who's going to support all this? Every single product that comes in, if you're an enterprise, of any serious scale, you need at least a couple people who are going to be able to support it and understand it at a deep technical level. Because, what if the first person is sick? You need the second person, maybe you need even three. And so this all becomes part of your economic model. So it's not obvious, and it's not all a matter of simply saying, well, in the name of innovation, we just let everything come through. You still have a problem of understanding what it is you have. And if you don't understand what it is you have, you are flying blind. And the risks and the costs are real. Hopefully most of us know that Equifax took material hit to its market valuation because it did not address an Apache Struts vulnerability, CVE 2017-5638. They did not address it in a timely way. This is well known. If you're not familiar with this case, I encourage you to read up on it. On the flip side, you can be very good about patching things and then discover that stuff is breaking. You need regression testing. And the more heterogeneity, the more variability you have in your tech portfolio, the more regression testing you have to do. And so again, you have some pretty clear economic incentives for also minimizing the number of products that you are running in your enterprise. And at the end of the day, it's a hard economic trade-off where you put in too high of barriers, you put in too many controls, you slow yourself to market, you slow your time to market, you introduce cost of delay, you run the risk of competition outpacing you that I mentioned. But if you allow too much diversity in, then you've got all the other flavors of pain that we've been talking about here with support and security attack surface and all the rest. And so I really start to hone in I start to hone in on the package manager, where JFrog got started, but is no longer limited to, as one of the most critical control points. And this is absolutely one of the pieces of guidance that, as Forrester, I am telling my customers. I am saying, look, If you can't put in the tall gates, you can't put in the heavyweight pre-approvals and have enterprise architecture stroking their beards at, you know, some product and coming back in 8 weeks with a yes or thumbs up or a thumbs down, then what I suggest to you instead is put in place a policy that everything in your enterprise must be checked into a package manager before it's deployed. No other approvals. Now, if the package manager has a blacklisting capability, then you already can get in front of people bringing in stuff that really shouldn't be in your enterprise. But the bottom line is that in the case of unknown packages, you bring them in, you say, just register it. And that's a non-negotiable. You have to put it in the package repo. I don't want it even on the most remote from production sandbox laptop under somebody's desk. I don't want to see it deployed there unless it's in the package manager first. And if that sounds like too much bureaucracy, oh, I thought you were doing DevOps. I thought you were automating your deployments anyways. So why do you have an issue with putting it into the package manager? So you put it into the package manager, and then your governance, risk, and compliance processes, your software composition analysis, your release readiness processes can start to assess what it is people are bringing in while they are innovating, while they are developing. Because not every experiment pans out. They may move away from that package anyway. So why have a big high ceremony approval cycle around it? It may not ever pan out in your enterprise, but then as it starts to accelerate, as you start to see usage, then you can start to tighten things down and scrutinize it a bit more and figure out what necessary controls you have to put in place, because now you know what you have. And by knowing what you have, you're in a lot better position than a lot of other organizations are. And so in conclusion, I want to be sure that we hand things over to Lorelei pretty quickly here. She's got some great material for you. The developers are leading the transformation, but we still need some guardrails. And I really think that the package manager, the integrated DevOps pipeline constitutes these guardrails that can enable the innovation as the buying power, as the approval power more and more shifts to the integrated product teams, to the developers. We still have to have that security. We still have to have that governance. And I do think that by adopting these techniques and adopting an integrated pipeline, such as now offered by JFrog, that you can achieve the best of these worlds that we're talking about in this increasingly volatile, uncertain, chaotic, and ambiguous environment. And with that, Lorelei has, I think, an awesome, some awesome material here, more on to exactly how JFrog shows up for you in the real world. And so without further ado, my friend and colleague, Lorelei Catapan of JFrog.
Thank you so much, Charlie. So before we dive into the 5 key takeaways that and patterns that are leveraged by our enterprise customers, I'd like to first provide a quick intro to JFrog. All right, so JFrog was founded in 2008. It was founded going to market with an open source project that was developed a couple of years prior to that, which was the world's most artifact binary repository management system known at the time. The founders of the company realized that the old way of doing business and storing artifacts and source control, which Charlie alluded to, is no longer going to cut it for modern agile methodology, increasing velocity and so forth. And so hence they introduced this new tool, Artifactory, as a binary repository manager. And ever since then, JFrog has continuously expanded horizontally to provide an end-to-end DevOps platform. Currently, JFrog has about 5,600 paying customers, and 65% of the Fortune 100 companies are among these customers. Our customers are span a wide range of enterprise companies through various verticals, from finance to retail, accommodation, food services, and so forth. So we see about 150 new customers being added on a monthly basis. We also provide several central repositories such as JCenter, GoCenter, Conan Center for these open source community to allow for that rich metadata-based open source packages that they can depend on a daily basis. We see as much as 2 billion downloads per month across our centers, including your Maven packages, your Go packages, Conan, homebrew packages, and even packages for your Android framework development. So from an enterprise usage perspective, we see about 3 million developers across the enterprise customers logging into the platform on a daily basis, such as through the UI or using their CLIs. And we also have a large team of developer relations and evangelists who are invested in helping the community to scale up and take advantage of modern technologies and DevOps best practices. And we're a DevOps unicorn. All right, so just a high-level summary of the JFrog platform that you see here. JFrog offers a unified DevOps platform. As I mentioned before, we started with Artifactory as a universal artifact repository manager. It allows for a centralized repository across your organization where developers can store all types of binaries, including container images. We often call it as the database of DevOps, where the building blocks of your software are stored, including the metadata information about the packages that make up your software. And then here in the middle is X-Ray, which we introduced in 2017. It's our DevSecOps solution, and it scans your binaries for security vulnerabilities, as well as your license compliance. And it's a software composition analysis tool. It's tightly integrated with Artifactory, along with the rest of the platform. Also, X-Ray is universal in that it can scan various types of packages. It's also a continuous and proactive security tool in the sense that it has a very efficient impact analysis capability. In other words, for example, any new vulnerability that gets identified on a component, X-Ray can detect all of the packages and images that contain that component. And hence, the impact analysis of this vulnerability is very efficient. X-Ray doesn't need to rescan the packages as well. Then there's distribution that allows you to bundle the packages that make up your application into a release bundle and distribute those release bundles into your edge nodes or your production sites, whether that's your data centers or your various regions in the cloud or multi-cloud, or for your IoT devices that are running your software. Then there's the pipelines down at the bottom that just recently went GA early this year. It's our next gen CI/CD orchestration tool. It's an outcome of us acquiring the company called Shippables a year ago. And pipelines also allows you to automate and orchestrate your entire end-to-end software delivery lifecycle from code to production. And then on top of it all is Mission Control that provides insight into your artifact usage, your trend in storage, your health of your services, and so forth. So, and of course, you can consume our solution anywhere, from open source, self-hosted on-prem or in a hybrid cloud environment, as well as a SaaS solution. All right, so going back to what Charlie was talking about, how knowledge workers are entrusted with leading the enterprise DevOps transformation in very large organizations. We know that the DevOps in enterprise is different. It's very different. Enterprise DevOps may likely have to deal with high volume in terms of developers, applications, development and production environments, different release cycles, different pipelines, workflows that you need to support. There's also many interdependent complex systems, lengthy approval gates or change control processes, and there's high stakes, and you can't risk being the, if I may, next Heartbleed victim or the next Equifax. And in order to overcome some of the challenges faced by enterprise DevOps, you need to be able to be nimble, be agile, be modern, and of course, look cool doing it. Lastly, because the maturity, your velocity and quality of your software releases becomes very much of a competitive advantage, it's important to respond to market changes and overcome these challenges. So when we look across our enterprise customers, we see that the developers are the ones that are leading the charge as knowledge workers, which Charlie had talked about. They tend to have the best ideas and experience of the best practices and the best patterns to balance some of the things that we've been talking about and to enable software delivery at scale. So Also, tooling and processes that might have worked for some simple use cases often fail when applied across large scale software. So to scale and enable enterprise continuous delivery, we need to answer some challenging and hard questions. Like, for example, how do you improve developer productivity and velocity without having to sacrifice governance and security? How do you streamline your processes and your organizational alignment without sacrificing the flexibility and freedom of your freedom of choice? How do you support thousands of developers and applications and pipelines on both your legacy and your cloud native without getting buried in these plugins, tools, spaghetti scripting, and so forth? So listening to our enterprise customers, we see that there are 5 key patterns that they're practicing in order to successfully scale in DevOps. So without further ado, the first principle that I'd like to share is the unification of DevOps processes and outcomes. And this really comes down to managing in one central location, both the process of your DevOps delivery pipeline, as well as the outcome of that process. So this is important because a lot of tools these days would let you do one or the other. For example, legacy CI tools would let you daisy chain your processes, but offer very limited to no visibility into the outcome of those processes. Consistency and traceability throughout the software lifecycle is also key to a successful DevOps process. As you know, artifacts are the building blocks of your software. It's what flows through your pipelines, and it becomes the fidelity of your software from development to your runtime environment. And having a single end-to-end solution for everything DevOps in terms of process and tool sets, this provides the visibility across your entire DevOps pipeline. And it improves your response rates, increasing velocity, quality, governance of your applications. This also avoids the need for context switching, which can be a hindrance for our developers, and also having a central universal binary repository that can manage different types of binaries that provides your developers that freedom of choice of what technology they'd like or need to use, whether that's Maven, NPM, Docker, Helm, anything in between. Also having a centralized, secure management of tools that span from code to production, which includes your binary management, container registries, security scanning, delivery and distribution, and a CI/CD orchestration tool can provide unique visibility and traceability of your entire DevOps process. And you'll see in the demo later that the JFrog platform provides this capability of being an end-to-end DevOps solution. It allows you to know, for example, the status of each artifact that make up your software at any stage of your pipeline, the status of your builds and what make up your builds so that they're reproducible, the security status of your packages at any stage of your software development lifecycle, what artifacts and packages are included in your release bundles, where were those release bundles distributed to, etc. All right, so the second best practice coming from our enterprise customers is incorporating that DevSecOps and shifting left. Today, we know that 60 to 80% of application code is comprised of open source components. And application vulnerabilities is the #1 source of external attacks and breaches, and we need to mitigate that and manage the risk. We see that enterprises today are experiencing an explosion of software. They're producing more and more artifacts, especially for the microservices-based application. And these applications could contain hundreds of container images that includes hundreds of various Docker layers, which then introduce a wide attack on the wide surface attack from vulnerabilities. All at the same time, these enterprise organizations are facing the challenge of having less and less time to react to these vulnerability attacks. So we talk to our customers and they want to do the right thing. They want to test everything. But sometimes security testing and scanning can sometimes be a pain. They tend to be pushed towards the end of the software development lifecycle until they have that Lord of the Ring moment where the CISO says you shall not pass into production. And this challenge with security is compounded with the ratio between the developers, your operations, and your security analysts. It's been known that for every 200 developers, you have 5 operations, 1 security analyst running around trying to achieve order. Hence, you have to be able to shift left with security in order to adopt the DevOps at scale. And enterprise developers understand this. They understand the need to shift left with security and mandate DevSecOps. They want to know, for example, what security vulnerabilities may be plaguing their open source or their third-party dependencies, what license are being used by these dependencies. And both of these, they ideally would like to know through their IDE. This is the tool that they use day in and day out, even before they even commit their code. So having a tool that allows developers to shift left and one that has tight integration with the rest of your DevOps ecosystem, including the IDE to avoid context switching, is very much of a key practice. In addition, having container security as part of your single end-to-end solution allows your developers to focus more time developing software and less time context switching from tool to tool. Also, our enterprise customers, as they scale DevOps in their organization, need a governance that can scale with them and provide them security and compliance visibility at any stage of the software lifecycle. And this visibility should allow for actionable insights. For example, they need to be able to set up security and compliance policies depending on the maturity stage of the software development. So they may need to, for example, set some very strict policies in place for software that's about ready to be released. However, they may need to loosen those policies a bit on the earlier stage of the development to avoid those alert fatigues for developers. Also, our customers want the ability for our CISO, the security team, to have visibility of all of the vulnerabilities that may be impacting their application so that they can analyze and prioritize what needs to be patched now, immediately, and what can be mitigated later. It's really about managing risk. The third best practice that we hear about a lot from our enterprise customers is the future proofing of their software using cloud native architecture and also enabling the modernization imperative. As many large organizations future proof their applications, they're leveraging Kubernetes, microservices, and all these loosely coupled architecture. And with that in mind, having a DevOps platform that allows you to build and deploy both the cloud native as well as your legacy applications is very important to enterprise DevOps. So in other words, you still need to be able to update your legacy applications to keep the lights on, but while developing these greenfield applications that are based on modern architectures. Hence, you need to support both types of workloads and both types of delivery pipelines within the same system. So that there's really no need for context switching, tool switching, and so forth. Keep in mind that continuous delivery for a Kubernetes application is different from your legacy applications or your legacy CI system. And you need to make sure that your DevOps toolset supports both types of systems. All right, so and related to that, the other common pattern that we're seeing for scaling DevOps that's led by developers is the pattern of pipelines as code, which Charlie also mentioned, and also the pipelines of pipelines. The ability to define pipelines as code and to store these pipelines definition in your source control makes them reusable, auditable, and reproducible. And this also eliminates redundant work among development teams. The patterns that we're seeing in pipelines as pipelines is when your organizations define the building blocks that they need to standardize for their workflows and processes. They then model these standardized building blocks and processes as code, preferably something declarative to avoid these spaghetti scripting or heavy lifting. And in order to allow different teams to leverage the same pipeline as code, they parameterize these building blocks. So for example, different teams may have different parameters for their database configurations or for the nodes where they need to build or test their applications. In the old way of doing CI, every team tended to build their pipelines from scratch, and then having to reinvent the wheel every single time and create their own processes and their dependencies. So rather, we've heard from our customers that an efficient and more effective CI/CD tool for them is they should be able to support this reusability of pipeline configurations, the parameterizations, conditional execution, and some other common constructs via some simple declarative way as opposed to an imperative way. Lastly, a CI/CD platform should be flexible. It should be flexible enough to be able to grandfather these legacy workflows while at the same time allow for modern cloud native development where teams can asynchronously integrate with pipelines of pipelines. This is because, for example, most enterprise organizations in their DevOps journey will likely not start from scratch when building their delivery pipelines. They'll likely have existing processes or CI scripts that may contain some old legacy bash scripts that kind of no one really knows about, but is still required as part of the release pipeline. And this allows teams to be able to gradually modernize those legacy processes, first by triggering them from a modern CI/CD tool, then finally with time, refactor them to modern practices. So lastly, you'll want to keep in mind your team topology, as well as the lifecycle management of your workflows. These two can affect your pipeline design. And what we've seen in enterprise organizations is that they basically have a pipelines team that is responsible for selecting all of the CI/CD tools that are used throughout the process and building the processes and workflows that can be applied throughout the entire organization. All right, so finally, before we go to the demo, I'll leave you with a best practice that one of our customers call, which is to think global, but act local. One of the key attributes of DevOps is system thinking, or thinking holistically about your entire DevOps ecosystem. And this involves taking into consideration your global or your organization-wide processes and tools. At the same time, we need to allow for that flexibility, that agility for the needs of each team. So, consolidation doesn't have to come at the expense of autonomy or flexibility or your velocity. An example of this practice implemented is when you select your tools that you need to make sure you can assign, and then you want to make sure that you can assign these fine-grained role-based access control to these tools based on the roles and the responsibilities of your teams and your users. And last, having that flexibility to interface with your DevOps processes and tools, whether they're based on legacy or modern, empowers your DevOps teams with autonomy. So in conclusion, this practice reduces the drift, which Charlie has mentioned, and avoids everything becoming as snowflake workflows and snowflake configurations. All at the same time, it ensures compliance as well as flexibility to support any tools or process in your DevOps ecosystem. All right, so with that, let's go to the demo to see how we've implemented these 5 best practices with the JFrog platform. Let me go now to my demo environment, which is this one. So here, this is the JFrog platform. This is the UI of the unified platform. What I'm showing here is a topology of all of my platform deployments across the globe. The lines represent the replications among the different platforms. I click on trends, I can see also trends on the storage, but I can see also trends on distribution, replication, as well as the X-ray scanning. Now, at the heart of the platform is Artifactory. The packages, this is a central view of all of the packages and binaries that are stored in Artifactory, along with the metadata information for each of the packages. So you can see at the summary level, whether it's been scanned by X-ray, the license information, number of versions, number of downloads. And then if I drill down into a package, what I see are relevant information depending on the type of the package that I'm looking at. For the NPM, I see the NPM install instruction. And then I see, for example, if I click on one of these, I see the README file. Now, let's look at one of the Docker images, for example. I'll look at Docker app and look at one of the tags. what you'll see is the Docker layer. So very relevant to a Docker image. You can drill down into each of the Docker layers. The other thing about this is that for every artifact, package, image, whatever it is, you will see information coming from X-ray. So this is the list of the violations found for this Docker image, as well as the security vulnerabilities found and identified for this Docker image. Here's the builds. Here's a centralized view of all of my build infos that are pushed into Artifactory. And these build infos include important information of the build, such as the modules that were published, the environment variables that were used as part of this build, the dependencies that were consumed. That's provided in the build info JSON. Of course, the information coming from X-ray. You can also diff this build. So maybe your latest version of your build failed. You can diff it from a previous version that may have passed and see exactly what changed. So you can see, for example, what environment variables were changed between those two builds. And then this one looks like it didn't change, this one got changed. Then I go to the artifacts. So this is the tree view of all of the repositories and all of the packages inside each of the repository. I can highlight, for example, and see, drill down in one of these Docker repositories. Let's look at the Docker pod local registry, look at the Docker image, look at the tag. Here you'll see some metadata information for this Docker image, the affected permissions, meaning what users and groups have access to this Docker image. Of course, information coming from X-ray. Looks like this Docker image has been blocked for download because of a violation. This is the list of the violations again, security vulnerabilities. Let's look at one of these security vulnerabilities, in fact. On the left side, I see the summary of the vulnerabilities, the severity level, and the component that was impacted by this vulnerability. On the right side, you see how it relates to the Docker image. It's a Maven package inside this jar file, inside this Docker layer, inside this Docker image. You may be wondering, what packages and other Docker images may contain this component. You want to do some impact analysis. So you can click on this component, look at the Answers tab, and see what other packages include this component. All right, so as you can see, one of the best practices that I mentioned is having a unified process and outcome. And the JFrog platform allows this, having a single end-to-end DevOps solution for your organization. And because of the universality of the platform, there's no need for your users or developers to have to context switch between tools, whether they're looking at a Docker image or an NPM package. All right, distribution. So this is the central view of all of the release bundles that have been created. The release bundles group together your artifacts or packages that make up your software release. It provides the bill of materials for your software releases. Important thing to note about these release bundles is that they're immutable and they're also secure. Here I can immediately distribute a release bundle. I can drill down into a release bundle and see what are the artifacts that make up this release bundle, and of course, what are the violations and security information related to this release bundle. I'm going to skip over pipelines for a minute. Here's X-ray. So X-ray is our DevOps, DevSecOps solution. So X-ray allows you to define policies and watches. So here's a centralized view of all of the policies defined in the platform. And you can define them as much as you need. Policies enable you to create a set of rules in which each rule defines a license or security criteria, and it allows you to define the corresponding actions according to your needs. So I can define here a security or a license-based policy, define my set of rules. And for each rule, you have a criteria. You can define the minimal severity, low, medium, high, or a range of CVSS score that you're interested in, and then define the actions in case this criteria has been met. So you can generate a violation. You can choose to trigger a webhook, such as Jira or Slack. You can notify a list of recipients. You can notify the deployer of the package that have this violation. So because the tight integration between X-ray and Artifactory, the platform actually knows which user, which agent deployed every single package that went into Artifactory. You can block the download of a package that had this violation. You can block the distribution of a release bundle that had this violation. And lastly, you can fail a build that may have dependencies that have this violation. In addition to that, to the DevSecOps solution, for developers to be able to shift left, I wanted to show you also the IDE integration that we have. In this case, I'm showing you a VS Code IDE integration that we have with X-Ray. We also have integration with IntelliJ as well as Eclipse. What I'm showing here is a Go project. I have some dependencies of my on my project. These are the dependencies of the Go modules. The ones that are underlined are those that have been identified by X-Ray that have vulnerabilities. So I can hover over and see more vulnerabilities, more information about the vulnerabilities. I can click on this icon to see component details and the issues of each of the vulnerabilities that I identified. Here I see that the fixed version is 0.13 for the vulnerability. So as a developer, I can change the version of this module to be able to remediate that vulnerability. All right, so moving back to, well, before I go there, one of the things I wanted to mention is that with the DevSecOps solution, it allows you to be able to see the security information across your entire software lifecycle. And whether you're looking at a package or a build or a release bundle or even at your IDE, X-Ray provides you that awareness of your security and license compliance across each stage of your pipeline. All right, so moving back to the platform. All right. Now moving to pipelines. So before I dive into the actual pipelines, I first want to walk you through some of the concepts and artifacts that you can centrally manage as part of pipelines. So integrations, this provides a centralized dashboard to manage all of the secrets across the organization. An integration allows pipelines to connect with an external service or tools such as GitHub or Jenkins or many others. And pipelines provides out of the box different types of integrations for you. This is the list of all of the different integration types. If you don't find one that you need, you can just create a generic integration and provide the relevant keys or secrets for that integration. All right, so you can also scope your integrations. So you can scope them by pipelines or by teams. So for example, you may have some secrets that can only be run by a certain team or be run by a production pipeline. Another thing about integrations is that you can have one central place to be able to recycle your secrets. So if you needed to recycle a secret, you recycle it here once, and all of the pipelines that use this integration will be able to leverage that new secret. All right, so pipeline sources. So all the pipelines are defined as code in a YAML file in a declarative syntax and are stored in a Git repository of your choice, whether that is GitHub or Bitbucket. And you import your pipeline configurations through the pipeline source. So when you make a change or commit a change in your pipeline definition in your source repository, it'll automatically get synced through the pipeline source. All right, node pools. This provides a centralized dashboard to manage all of the node pools that can be used across your organization. Node pools provide a convenient way to logically group the nodes where your pipeline steps will run. So you can group them by operating system or architecture, group them by teams, or even the size of your memory of CPU of the node pools. So for example, you may have some pipelines that focus on the load testing and the performance testing. You can define those set of pools that have larger machines. You can also manage your quota across your teams by defining which teams can actually use these node pools. You can define a dynamic node pool or a static node pool. Static nodes are those nodes that are persistently available. The dynamic nodes are build nodes that are spun up and torn down on demand by your pipelines. And this can help manage infrastructure costs by not incurring charges on those idle nodes. All right, now drilling into pipelines. I'm going to focus on these three pipelines representing three different teams, 2 development teams and 1 release management team. The development team builds an application with 2 different components, a front end and a back end. Another development team building a Go service alongside the application, and the release management team that wraps up the application and the service into one distribution release bundle so that they can distribute it to a production environment. Looking at the service workflow, each of the builds, each of the boxes represent a step. They can be a native step or a generic step. In this case, this is a native step that uses a Docker build native step. It comes out of the native steps come out of the box with pipelines, and these steps know already and what commands to execute and perform an action, such as pushing a Docker image and so forth. The circles represent the resources. They can be an input to a step, or they can be an outcome or an output of a step. So resources are global, so they allow pipelines to be able to trigger each other through output and input resources. So this one is basically building a Docker image and then pushing that Docker image using the Docker push, creating the build info, and then eventually promoting that build info with an outcome of a promoted build info. And this output resource is going to be consumed by the release management team, as you'll see very soon. And then the demo application. So here, what you'll see is it has two entries, two entry points. So each of these entry points represent an input resource. In this case, this one is a GitHub repository that contains the source code for your front end, and then the GitHub repository that contains the source code for your back end. And a change in either one of these GitHub repository will trigger this entire pipeline. This is actually a generic step. So with the generic step, it allows you to customize and run anything that you need in case there's not yet a native step that's available. So you can run your legacy scripts and your Python scripts and so forth. At the end of this workflow is a promoted build info that describes the Docker image of this application. And then let me just show you the YAML. This is a definition of the pipelines. So it's a declarative syntax. As you can see, it's a very simple, lists all the steps, the input resources, and so forth. Let's move on to the release management. Quickly, it's got two input resources, and so each representing actually the output resource of the other two pipelines that I described. It creates a release bundle and then eventually distributes that release bundle. So the release manager doesn't have to go to Slack or email to understand whether the application or the service changed. They can look right here in the same platform and then determine whether to go ahead and trigger this workflow. So with that in mind, just as a conclusion, one of the best practices that I mentioned is pipeline as code and pipelines of pipelines. And here you see the JFrog pipelines enables you to do that. And it provides continuous collaboration among your teams. And last, with thinking global, acting local, with the JFrog platform, it provides your DevOps team full visibility of your pipelines, but still allows for that flexibility among your teams, regardless of what tools they're using. And with that, I conclude my demo. Let's see, I think if we have some time, I don't know if we do, but if we have some time, we have Q&A.
Well, unfortunately, we don't have time. We're 2 minutes to the end of the webinar, but I do want to thank everybody who did submit questions. Just please know that the folks at JFrog will be getting a copy of all of the questions, and so they'll be more than happy to follow up with you offline. Before we close things out, let's go ahead and do that drawing for the two $50 Amazon gift cards. Our first winner today is Michelle C. Congratulations, Michelle. And our second winner today is Sandesh T. Congratulations, Sandesh. We'll be following up with both of you offline via email to get your $50 Amazon gift cards over to you. So please check your inbox. Want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Lorelei and Charlie, thank you so much for your time and your expertise today. It was a great presentation.
Thank you.
Thank you. My pleasure.
I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.